pressing in on your eardrum.
You want to put bubble on the... What's going on there? That's our victim, okay. In theory.
Got a nice view of some animals. We've got some Brisingid sea stars, some crinoids in the upper left.
So I know it's not Wayne over there.
Hi, it's Ashley.
Good morning, Ashley. Can you zoom in a bit for me, please?
Sure.
Perfect, thanks.
Those zoanthid anemones on the right?
Yeah, I think so. They're in the wide view on the lower right. There's some sort of stalked coral
Something.
or I don't know what it is. Maybe we'll get a better view.
Things are happening.
Okay, Ashley, you can zoom out again. Thank you.
Okay,
See
so
near
do
the
you
arm?
see that spot I was talking about? There's like 4 octopuses almost outlining a little hole, just to what seems like a milk crate's distance to the right.
Yeah, Roger, I see it. What I'll do is I'll get closer and then I'll let you guide me in. I'm just going to have a wide view here too.
That's a grenadier. I think it's Armadas.
You want to bubble back to number 1 now? So I can just keep an eye on that cable. Just want to make sure it's not hung up on porch there. It looks okay. Okay, Ashley, you can zoom in a bit there.
Okay, moment of truth. What's the oxygen do?
What's your prediction?
Well, based on what I understand about gases and temperature, it should go down. But okay, we're seeing an increase.
Do you want bubble on the probe now?
I can
Increase
come.
What I would
oxygen?
expect. Yep.
I can come down faster or slower, or now you can drive me wherever you want.
Okay, just over to your right. A little, a little, a little, a little, little more. Okay, stop.
Okay.
And either kind of, if you can rotate almost like you're going to stab the outcrop from a 90-degree angle from where you are, that's great. And if not, then just straight in where you...
Rotate counterclockwise there.
Yeah, so if you were to rotate like up.
Rotate up.
Actually, you know what? Right here is good. Just stick it in.
So, sorry, I rotate with respect to the manipulator.
Yeah, it's like if you were going to flick your wrist upwards, if that was your arm, to give like a thumbs up
I do.
kind of thing.
The other thing that helps me if you just reference on the screen, so you want it up, left, right, down.
Like projecting into that hole, like if you were going to enter that hole perpendicular to the plane of the surface, planar surface of that hole.
So you want the tip of the gun parallel to the bottom of the screen?
Yes. Yes. Thank you, Amanda.
Tip of the gun parallel to the bottom of the screen.
Yeah, so if you just want to measure, like go in with this.
Basically, you want the tip in a diffuse flow.
Yes, that's exactly what I want.
Say bring the tip to the northeast of the screen.
Sorry,
Yeah,
sorry.
okay, oxygen just went down. This is good. I dropped my pen. That is bad.
Is it possible to get the temperature and oxygen sensor screen up on the chart computer?
I got it. Okay, oxygen's going down. Let's can we stick it in more? Can we like get it so it's like in
yeah,
that hole?
I'm just checking the cable there.
What
So.
computer is that on?
The monitor's black right now.
Yeah. Is it one of our computers or one of yours?
Yeah, I think it is. It's this monitor here.
Yeah, the temperature DO logger that we're using right now is hooked up through the ship system.
Maybe the monitor's just off.
Yeah.
Do I
Do you
just
know
press?
which computer?
I thought it was the chart
Are you
computer.
looking at it now?
Yes.
Roger. Thanks.
Sorry, girl. Sorry.
Sorry, not to understand your question, Miles.
So I can go down on the screen right here.
Yeah.
To the right. I'm touching the animal and.
Okay. Let's just go down. Oh, kind of right in between those two octopuses.
Yeah, can do.
And it's okay if the probe touches the rock. It's just the probe itself is actually cased inside of that whole housing, so it's not going to damage it.
Yeah, roger. The girl behind us is behind the probe. I was touching her a little bit. So.
Oh yeah, this is sweet. Okay, so we have an increase in oxygen. We're at oxygen. We have our temperature is 6.6. And remember, our ambient was only 1.7, so we are higher. And our oxygen is at, this is weird, 80.9. So that's about 40 millimolars. Sorry. Yeah, 40 millimolar lower than it was before. I don't know what it is. Okay, that's great. We can put a temperature probe there, but before we put this down, is it possible to rotate your arm? So, no, we just talked about that. You can't do that. I guess what I'm trying to get you to do is like poke around in this spot just to see if the temperature within this like very small area that we're right next to varies from 6.6 and 80.
Yeah, I can. Let me back out of here a bit, and so I can rotate this guy. I'll give me just a little more slack here.
Was that a little baby that just wiggled itself by, or is that a different species?
Oh, I didn't
see it.
Oh,
Sorry.
it was over by the whitish yellow anemone.
Ashley, can you zoom out for a second? Thank you.
I don't know where he went.
I don't see it, but it is possible. So Chad, when he went out in March, was able to see a few juveniles.
Okay, zoom back in again.
From the egg masses. So we know that there are viable, hatchable juveniles that can hatch and swim away.
Oh, that's fantastic. Maybe another one will hang out with us.
Maybe you spotted it. Yeah, keep an eye out for those. We want to see different life stages, ages of these guys, because what we see right now are these fully aged, obviously mature adults, and then we see the hatched babies, juveniles, but we don't see any of the stages after that, so we don't know where they go after they hatch free.
Oh, so they may stay here, or they may go off on an ocean journey somewhere.
Maybe. Given how this species is...
Okay,
zoom out again,
that's fine.
Nancy, please.
If you can't make it work.
Yeah, I'm going to try and rotate the probe around, and I'm going to use a rock to align it a little, probably. The probe's hitting the animals before I get to where I want to go. That's what we want. Okay, Ashley, you can zoom in again. That'll do. Thank you.
Yeah, now if we could reach the upper part that we weren't able to get before. Kind of like stick it in there as far as you're able to. Yes.
I had to rotate to, so I'm touching her there. Maybe I can go just above her.
That's great. Just hold it there for a second if you can.
What temperature and oxygen are you seeing there?
We're seeing a temperature of about 4 and an oxygen of 100. And so it seems like we're going to want to stick the Osmo sampler probe closer to the first spot we put it, which is near all those white, what are probably little tube worm.
Yeah, I would,
crusts.
in my humble opinion, that a concentrated diffuse flow is coming out in the lower right of the corner picture there.
Yep. Okay, so let's put that as one of the Osmo intakes.
Okay, you've got your readings here, do you?
Yeah, I got it. Thank you.
Coming out. I might be able to get a little further in the diffuse flow here now.
Oh, you know what? Try refreshing your page.
Oh, yeah, I think that's a great call there, Dan. How does that look?
Is that hotter there, is it?
Can you see the temperature and the deal there?
Temperature is... Yeah, actually, you know what's weird? That's not as low as the other spot was. But it's still a change. It's still different than the ambient. So I think... Oh, wait, it's where it's dropping. Why don't we stay here for a quick second?
It's
okay.
What was that?
Did you feel something move below you?
No, I touched a button on the master and made the arm jump.
Looks like the ROV's moving a little.
It is. I think I'm
falling.
I'm pushing on the, so the probe's touching the rock there.
Okay.
There we go.
This is comparable to what it was before when it was low. So I think this is the spot we're going to deploy Osmo sampler. I feel comfortable at this point.
Okay.
When you get a chance, could you tell us a little bit more about this Osmo sampler? What are you looking to sample here?
So the Osmo sampler is basically just it enables us to take a long record of the fluid discharge. And so the osmosis part is that you basically create a pressure, a salt gradient.
Okay, so you want to zoom out for me, please?
It's going to suck the fluid in constantly. And so we start sucking in fluid before we even deploy it, right? And then when it gets deployed to the bottom of the ocean, you can see a change in that fluid to the deep bottom water. And then it'll be deployed until we pick it up again, but it will only be collecting fluid for as long as there's capillary tubing, which is about 12 months. And at the end of the 12 months, when we recover the instrument, that capillary tubing, because it's so tiny, it really limits the diffusion or the amount of mixing that can happen within the tube itself. And so you get a pretty pristine record, a timeline of your water.
Sorry to interrupt. Do you want to poke around with this anymore, or are you happy?
Well, we might have to find a second spot for the other T-probe.
So do you want to poke around while I have
Not the other T-probe, the other Osmo intake. Yeah, I want to poke around. Can you zoom out? I think we're kind of on top of the crevice, right?
We are,
we
yeah.
were just looking at like the top portion of it, or were we near closer to the bottom of it?
No, we're up at the top of the crack there. Here, let me move that manipulator out of the way.
I think
so
that area
up by the anemone in the top?
Yeah.
Yeah.
The enemies in it. See an enemies right behind the manipulator there.
Can you reach it?
Can I reach it?
Yeah.
Possibly. I can reach it. I don't know if the probe's got the.
And can the Osmo sampler reach that far?
Osmo sampler should be able to reach that far, yeah.
Okay.
Even that kind of hole right below the anemone, see how there's that little orifice, almost shaped like a toilet bowl.
Probably in the light bar there.
Amanda, you see this frilly stalked thing? Maybe it's just a black skeleton with zoanthids on it.
I'm going to get closer to the screen. I can't quite see.
That's, I'd have to adjust the ROV to get any more. I'm leery of stretching that cable any tighter.
that, Annie? He's as far stretched as he can. He may have to remaneuver.
Sorry. Okay. We can, I guess, if you want to position yourself back down on the ledge that we were on when we put the Osmo sampler down, we could try to get some temperature probes at the closer to the bottom of this vertical orifice.
Okay.
You know, we're kind of like we're perched, right?
We are
And
perched
we're
on a
almost
marble.
looking over. Are we? That octopus below us? Is she in? She's in the crack, right?
I think that's a.
You can see her through the grate. Can the probe
me
reach
look.
down? Can it reach straight down and measure the DO from that area, so we don't have to move at all?
Yeah, there's quite a clutch right below us. You can see in the bubble cam there.
Yeah. Why don't you? There's like a little gap. Can you stick the probe in between those two octopuses, opening that hole before they
might be
close it off?
umbellapathes.
Right below
It
the
might
probe
be.
now.
Uh-huh. Yeah.
Yeah, might be able
They're
to
opening
reach.
up for you.
Or is it not a? Yeah, I guess it's umbellapathes. Or is it not a crinoid?
Yeah, sorry, the camera angles aren't optimal, but I to get this close to use the probe, I had to trade.
That's cool, but I mean, can you reach? Are you reaching?
Yep, I would say I'm touching there. Let me just come up a little. Ah, I did, didn't I? Okay, what do you get there?
Nothing special.
Really?
Yeah. I can't see shimmering on the bubble cam though, and I'm just not sure if that's because the resolution or if that's because there's not shimmering on the bubble cam
Yeah.
from that spot.
It's quite a ways down there, and the light's not too great.
Well, okay, so could we put down that probe for a second and take out Herc's probe and stick that into the hole since it's a little longer?
Yeah, I can do.
Oh, actually, let me stay there for a second. We started to get some readings on them.
Yeah, I think I can
register.
wiggle down in there a little more.
This might be our second spot.
You can see a little
this
shimmering
is good.
water.
Yeah, this is low. This is high and low. Okay, so this is... We're at 76.9 micromolar and a temperature of 8, which is the highest we've seen in this segment.
There's quite a concentration of octopus down
Now
there.
it's 8.9.
Okay,
This
so
is good.
let's do some stuff. Let's take a squeezer, drop the 2 of the temperature probes, and deploy the Osmo T-handles in this spot. See where that takes us, and then I'm pretty sure the RBR logger is also going to go in this area, right?
You're happy with the reading with the instrument I have at the moment?
Yeah.
Yes, I'm happy with these. These are good.
Now it's 9.5. This is great.
This is the spot.
So I can stow this guy then?
Yes, please. Thank you.
Freeze button fail.
So, I don't know, I guess the The squeezers are probably the easiest to do first, because then nothing's in your way. And you have to use that funnel.
I think we want to, what we talked about was deploying the instruments off the porch first.
Okay.
Because they're in the way of grabbing the squeezers.
Okay. Amanda, do you want to sit now, since I don't need to see these?
I've got an interesting question here. What data do you have on how stable the currents are in this location? Do we know anything about how the currents are moving around?
Sorry, just one moment. We'll answer that. We're just having a little science
Negative.
discussion
I would
back
say
here.
it's just visual.
Okay, science, I can deploy some of these temperature loggers.
They're just discussing some things back here, and we'll be
Science huddle.
yeah, with you shortly.
Copy, standing by. Ashley, while they're huddling, you want to zoom in on the
Sure.
on one of the animals there. I can't give you any more pan right, unfortunately. Try zooming in there a little more.
Oh, that's a great view of those eggs right there.
Okay. That's what you see is what you get for the moment.
Tough with all the shimmering.
It's pretty calm out too. If you wanted to, you could try a bit of a zoom on Argus.
Hey y'all, thank you for tuning in to Nautilus Live. What we're looking at right now is one of our octopus brooding, not ours, one of the amazing octopus that are down here in the ocean it's brooding. So it's venting some water over their eggs. We're trying to understand a little bit more about the environment down here at Davidson Seamount. So if you guys have any questions, send them on in.
Okay, pilot, are you waiting on us?
I am.
Okay, so we're gonna place one of the T-handles in that first hole that we measured. If you can remember, it was the one with all the white tubey worms around it. They're not really tube worms, they're just tubular worms.
Okay.
And with that, we're gonna put one of the temperature probes. Ideally, it'll be the same color temperature probe handle as the Osmo T handle that we put in the hole.
Copy that. Okay, actually, you want to zoom out for me? I'll see if we can find a victim on the porch here. What about the big one there?
The RBR logger, so that's going to go in the hole with that highest temperature oxygen, which was the last one we just measured.
Okay, can I get rid of that one first?
Yeah.
So it's kind of sticking out there. If I inadvertently bump it with this beast of a manipulator, it would.
Are you talking about an octopus or the probe?
No, if I accidentally bump the probe with a manip, it'll knock it off there, so I'd be happy to get it first. You want to porch out for me carefully and see what happens? Yeah, looks like you can run it right out. Just wanted to make sure it wasn't going to hit.
Is that good, Dan?
Yeah, it should do.
Okay.
That's funny. It's not the most optimum T-handle angle. Who rigged this porch?
Was that Dan of yesterday who rigged this porch?
That's a good idea, Miles.
What you're seeing now is the deployment of a long-term temperature dissolved oxygen probe. And again, this is housed inside of that casing. So the probe itself is only about the size of a D battery. You can see it on the end there. It's that little blue thing. And so we're going to stick that into the last discharge or venting orifice that we measured between those octopuses. And that temperature that we measured was 9.5 degrees C with oxygen at 62 nanomolar, which is higher and lower than bottom water respectively. So bottom water temperatures normally around here is about 1.7, and bottom water oxygen concentrations are about 120 nanomolar. So we're looking at 5 times the temperature and half the oxygen, which is...
So talk to me about the orientation of this thing. As it
basically straight down, just like you had with the original when you used the other probe. So yeah, that
something
blue
like
thing.
that.
Yep.
And
You might have to bump the ladies a little bit, but they'll go back to their position
okay.
after we get out of there.
Sorry.
Are you irising there? Or
Yeah, I had it open on the porch, but then it went crazy.
crazy iris?
Yeah.
So I think that's the hole we want. You can move bubble to the right just a little if you want. And up a little, perfect. Pardon me, ladies, pardon me. Sorry, sorry.
I don't know if they speak English.
Touching the rock there, as you can see Herc moving around. I see where I'm touching. Is that iris closed now, or what's going on there?
It's, I don't know.
That's better. Thank
Sorry.
you.
Once you have it kind of in a position, maybe take the top of the manipulator arm and press the top of it and see if you can push it down in at all.
So I'm gonna have to let it go there.
Okay.
As you can see in the HD picture, the manipulator is touching the rock there.
Yep.
So I can't come down anymore on the shoulder.
Okay.
It was pushing me back. I could try and back the vehicle up a little.
My only fear is that if you let it go now, it's going to actually tumble down the... Do you think it's can you feel it, the probe, is it in position in that hole, or is it...
It's hard to say, because
okay.
I would like to get down a little more.
Okay.
I think I'll back the vehicle up just a bit. Would be ideal to be able to see the probe touching, because I don't know how much, like, there could be 300 mil below the probe, or there could be 3. I can't tell you at this point.
Yep. No, I understand.
As we look at these lovely ladies that are brooding over their eggs, do we have any idea of how old they might be? Do we have young octopuses, old octopuses, or octopuses typically don't have that much of a lifespan?
Jennifer Brown, that's actually one of the things that she's really interested in, is trying to locate some of the juveniles, because so far at Davidson they have been able to witness the hatching of an octopus, which was really beautiful. That they observed, I think, in April when they were out on the Atlantis, and then in August they came out and they actually were able to find an octopus that was pretty well deceased. They're usually, it's kind of thought that when an octopus dies, it's scavenged by other animals, and so it's kind of unique and lucky that they were able to find that end life stage. But as far as you know, juveniles and before brooding, it's hard to tell.
Right a bit.
It's hard to tell their age, and
up a bit. Perfect.
so that's
right
a
there.
current research question.
So we've got some scientists out there. They're already asking our research questions.
But are the lifespan, we don't know. There was a Granellodon, which is a different genus of octopus found at, I think, in this area by Robinson, and their team observed that octopus brooding for 54 months, which is 4.5 years.
Wow, that's a long time.
I think that was up north, Northern California area, right?
It's a long time, and shallower octopuses are known to only live for...
Would that be brooding for almost their whole lifetime, or we have no idea that they would go off for maybe 4 years and then come back?
We haven't, as far as I know, we don't know. It's hard. These observations are hard to make, and
Oh, absolutely.
a lot of the octopuses look pretty similar, so it's hard to... Octomom, which is that octopus that brooded for 4 months, that was her nickname, she had a really distinguishing scar on her mantle that enabled them to go back and identify her year after year.
So I think if I let it go there, it's going to lean up against the rock.
Okay, great.
Happy with that?
Let's do it. Yeah, can you snap a picture, please?
There we go.
Thank you.
What's the name of this probe?
This is the RBR logger. RBR TDO, I think, is what Erin... To be consistent, I'd put T and DO in there, in the name.
Ashley, can you do a bit of zoom there for me? I don't know if you guys want to get a shot of that.
Right. Temperature,
Yeah, we
dissolved
can't
oxygen.
see the. Can we get the actual tip of the probe though? Zoom.
Yeah, if we zoom in on the bubble cam, if you center it up there. So
Is that probe's behind that octopus, kind of over that orifice, right?
yeah.
Okay. Yeah, that's great. Thank you. And so now
Okay,
into
you
that
can zoom out.
other spot that we measured, the first one, would it be possible to please get one of the temperature loggers and the Osmo probe? So I think there's a blue and green handle on the Osmo. So those are the temperature loggers we'll want to deploy here.
Blue and green. So there's 4 probes on there. 2 have a long, skinny instrument on them, and 2 have a short instrument. I thought they were all temp logs, but
They are all temp logs. They're just mounted to different types of
okay.
things. But to keep kind of consistency as far as sample processing goes later down the road, I think we should keep blue temperature rod with blue Osmo sampler handle.
Oh, Osmo is in down the hill Osmo.
Yeah.
I get it.
Yeah, so light colors.
You're pushing your luck there.
Trying to make things
So
easier
you
for
want to
scientists
put all
down
these
the road.
instruments on the cliff, and you want them color coordinated. Roger. So I'm colorblind. You're gonna have to help me out.
That one's blue.
Roger.
Good
Well,
guess.
I'm not sure if I'm really colorblind, but every morning when I get dressed, my wife claims I am.
That is short. I haven't seen one of those before.
It's little. That's actually just the rod. The temperature logger is that little thing duct taped to the end. Not duct tape, electrical tape.
I was thinking there must be something missing, but that's it.
That's it. Yeah, they plug in with like a headphone charger and set up on the computer, press go. So I know this is going to be kind of hard to position, but can you lay it down almost? See how right behind where your probe currently is in the view of the main camera?
Yep.
There's a there's a spot with no octopuses.
Yep.
Kind of lay it down
Can do.
there, so that the O2 part is in the darker area where we would have stuck the probe.
It'll probably fall just like that. So
Cool. Okay.
I think that's in the. Ashley, you want to zoom in a bit there for me?
Same orifice.
Appears to be diffuse flow there. There's some kind of.
Oh, there's a baby octopus. Just took off. There it is.
There it went.
Oh. I think I got a picture of that guy.
I missed it.
So cute.
Oh, there he goes. There he goes.
Oh, this is so cool.
There's so many of
The whole
them.
clutch is going.
2, 3,
Oh,
4.
man.
Hopefully this is natural
Zoom
birth.
out.
This is
So
definitely
cute.
where we want to deploy our instruments. Wow, that was like 6.
So
Look
right
at him
between those
go.
2 ladies there,
Yep.
Oh,
Thank
there's
you.
Another
another
one.
baby.
I can go under the cliff a bit more, or
Yeah. If go kind of towards the rock.
towards the rock. It looks like some kind of
They're all hatching.
That's great. This.
bacterial
Okay,
mat.
if camera zooms in to the right, a little moves over. Is that one actually coming out of its? No, those are the tentacles. I mean the arms.
No,
Never
but
mind.
they
these guys
just
are
keep hatching
so
from below.
cute.
So you happy to drop
That's
it there?
yeah,
Ryan?
that's great.
Drop
Thank
it.
you, Dan. Oh, can we zoom out? Did we lose that? Okay, so it's behind the rock.
Can you see it?
Nope. Let's stick the temperature probe in that same, not the temperature probe, the Osmo sampler in that area.
Okay.
That one was the temp probe.
That was the
One
temperature
of the temp
probe.
probes there. Okay, Ashley, you can zoom out now.
camera where those young octopuses are hatching from?
I think it's the bottom right.
It's the one right behind the hockey puck.
Okay. Do you think we can see that with our main camera?
Not from this angle, no.
Hey, is that the probe? Can you zoom back up to where you were, please?
With the
On
bubble
the
cam?
the bubble cam? Yeah, that's the temperature probe that we just dropped. Okay,
Ooh.
perfect. Can you take a snapshot of that, please?
Do I have access to that camera as a data logger to take a photo of the bubble cam?
Not with capture.
No,
Bubble
it's
cam,
capture.
could you take a, can you guys take a snapshot up there?
Video should be able to record 4K though.
If that's the case, can we be recording much of this part in case we get a good view of those octopuses hatching out as well?
I just saw
See if
one
they can-
sneak by the very far left on the bottom of our bubble cam. So I think he came from under that bomb.
I'll be able to spin the vehicle around and get a shot with the main camera there once we
Okay.
get some of this,
Then,
some of these instruments deployed.
yeah.
So now, you want to get rid of the second temperature logger, but we don't know where we're going to put it yet. So is it possible to deploy one of the Osmo sampler handles that we know where we're going to put it? Just
Sure.
check more stuff off of our list. Or actually, you know what? Before we move, let's take a squeezer.
Good idea.
We get this great diffuse flow. We can put it right where we just dropped that temperature logger. So
Okay.
we'll do 2 squeezers, please.
And so you want to deploy the accumulator over that first?
Yes.
Copy.
I do. Amanda, do you want?
So we're deploying out these squeezers. Could you tell us a little bit more about what you're hoping to sample with these, how they work?
Hold on a sec. We're having a science talk. Hold on.
Absolutely. So while we're having a science talk, we've got a lot of questions coming in. We have a Lo from Japan. So glad that you guys are able to tune in and watch with us. Happy birthday, baby octopuses. Everyone is excited. They're so cute. This is a great opportunity to see this happening. Oh, and there goes another
There's
one.
another baby. Oh, there's another one
So
coming out right now.
cute.
And
2 more.
another.
Ooh, this is fantastic, guys. This is an experience,
Wow.
a new experience, life-changing experience, not only for the octopus, but for
Oh my
us.
gosh. Look at all of them.
Yeah, non-stop.
Beautiful.
Yeah, I
beautiful.
touch
See,
them
they
and
just
they
keep
come.
coming. Do you have any idea, like, how many eggs would be in a clutch? Or our scientists are still debating. We'll get back to that.
Do I dare let it go?
Can you hear me?
Oh.
Can you hear me?
Yeah, I can hear you.
Okay. So at the other site in the Pacific that this a large cluster of these octopuses were found brooding, there was between 25 and 35 approximately eggs in a clutch.
What was that instrument you just deployed?
So stinky baiter.
The stinky baiter?
It's a very non-correct term for it. It's what Mike nicknamed it.
It's a funnel, right?
So it's an accumulator, so it collects the venting diffuse flow there, and then we stick the squeezer in it.
Just trying to figure out what to log it as.
I dare ya. Log it as a stinky baiter.
But if you do that, could you also just write funnel next to it?
put it in notes.
Thanks.
All right, this is a squeeze sampler, right?
Yes. This is gonna be. This is itself is just the funnel part of it.
This
Okay.
guy is,
Not gonna work.
well, I thought it was sitting on a stable part, but as you can see, it tumbled when I let it go. I'll try again, see if it. Like no place to set it except my porch.
Okay. If we can't set it, that's.
No, I can set it in there. I need to set it down and re-grab it, so. Can I get bubble cam on that hockey puck?
Think so.
Gotta love intermission jobs. It's always the hammer, never the carpenter.
Doesn't look like a funnel, but
I'm gonna reposition the vehicle just a bit, guys.
Okay, whatever you need to do. For our viewers, this is a, you know, very complex science instrument called a funnel. So, or we're just, basically, this will be set over the top of where that warm water is coming out, and the warm water therefore will accumulate and, you know, basically fill that container up. And then one of the squeeze samplers, which samples water, will be placed through that rubber flange, the black part at the top. And so it'll be able to suck up the water, and we'll know that we're getting more concentrated water from the seeping fluid versus bringing in water from the surroundings, which isn't that vent water that we'd like to sample.
very clever.
Very clever indeed.
High tech.
I like how science is a mix of MacGyvering parts and super high-tech fancy. So like the squeeze samplers are pretty intricate in their design and how they drop the fluid. And then you have this funnel thing.
Is that funnel made out of PVC, like an end cap?
It looks like it. I
Looks
didn't
like
make it, but yeah, it looks like it. And those are
That
dive
is
weights.
exactly what it is.
Cool.
It's a PVC end cap with some lead weights and hockey pucks for handles.
MacGyver engineering right there.
That's right.
And a very poor grab by the manipulator operator.
Things you can get at your local hardware store.
It's amazing how many fantastic science tools we build from hardware stores.
It's part of the
Yeah.
fun.
It is.
It's also really fun when you go to the hardware store with this sort of design plan in mind and you talk to the people there and they're just like, you're doing what with this?
Oh, that's the best.
Well, it needs to survive the deep sea for a year. Does this corrode?
So they try and sell you all their titanium?
One time I did ask what they had in titanium there and they just sort of gave me these raised eyebrows. Like, what kind of projects are you doing?
Deep sea science.
Deep sea science. That's right. However, there are types of PVC that float and types that don't. So that one is an important question to ask when doing science with PVC.
So apparently scheduled 40 floats.
What is that, the type?
Yeah, usually the white ones are schedule 40, the gray and black ones are schedule 80. It's just a
Oh,
thickness and whatnot.
Oh,
You had to
look
add
at that.
weights, so
Look
I'm
at a
assuming
Klingon.
it floats.
right.
We do have a new buddy.
She will probably stay with you for a while now.
She's going to help us
Oh,
collect
she's
our
glommed
sample.
on.
Well, that's not helpful.
No.
Well, she holds it in place. She has
So
8 arms.
There you go, Octopus. Hold on to this for us just
I'm
for
gonna try
about a year or
and
so.
let go of there, but I'm not too hopeful.
Okay, that sounds fine. You can let go.
She may hold it for us.
Nope.
All right,
Oh,
okay, so
well,
the funnel
hopeless.
is not going to work. I don't think we should.
It's not working.
I think we should just try the squeezers. We'll do 2 samples. Try to get them as close to the orifice of the shimmering fluid as we can.
Okay.
Do we need to get that back first?
Well, we need to eventually bring it back. But for now, it's off the porch and kind of out of the way.
So are these our squeezers on the left?
Yep. And they're labeled, so on the sample sheet that Taylor Ann has, there's a setup for how the samplers are measured. So I think the top left one, that might be number 9.
Yeah, whenever you can see that number, let me know which one it is.
And we'll, if you could snap a shot of it when it's in the screen. The big mailbox numbers.
Okay, great.
And actually, the next time I should write them on the top. 2.
So I'm just playing with the grip force here to have a minimal grip on this thing and hopefully not drop it. Oh, that's painfully slow.
One of the things I didn't appreciate when I first started coming out with ROVs is how versatile the arms are. So this, what Dan is doing now is fairly precise work, and if he squeezes that too tightly, then it will suck up the water too soon. So the manipulator can be quite delicate and, you know, lift things and carry things like delicate sponges. But also they can crush rocks and, you know, be strong enough to lift really heavy objects. I'm not sure what the payload is on this arm, but usually a couple 100 pounds, 100 pounds.
Nice.
So this particular manipulator has a grip force setting, and right now I have it set to 2, which is we have 2 through 10, so maybe 100 or several thousand pounds of jaw closer force to just enough to barely pick up this instrument.
I do not see a number.
No, it's going to be on the side. So it's on the left. It's facing towards the outcrop on the left.
I'll show you the number after we do the squeeze, because then I'll have a full grip force and I can rotate it around. I'm afraid to rotate it now because I just have a real light grip on it.
Swell.
You all right with that?
Great.
I might be able to show you the number here. If you want to really want to see it.
7.
Number 7.
Lucky number 7.
And so as best you can and as deep as you can, once you feel comfortable with those things, then just trigger it,
Copy.
please.
Video, you want to zoom in there a bit?
How is it triggered? With a squeeze?
That's good.
Yeah.
That's why it's
Yes.
called a squeezer.
It's very much like a syringe, but slightly more dangerous.
Did you guys make these too?
No, they were designed by some folks at Mambari, and then I might be wrong on this, but I'm pretty sure the scientist tech who I'm out here for constructed this particular set that we're using. And they've been used on various cruises, as far as I know, since 2013.
So we're collecting some of this water, hopefully from the seeps. Is there anything particular in the water that we're looking for?
There's 2 different scientists who are going to be analyzing these samples, and one is going to be looking at the geochemistry, which is how the rock is going to influence the water chemistry. And then
Okay, I'm
that's
touching
great.
there. You happy to squeeze it?
I'm happy, that's great.
Squeeze
And then
it.
the other one's going to be a biologist, and he's going to be looking at much smaller, like kind of genetically what's living in the fluid itself. And those particular scientists are more interested in what's happening with the hydrology and the geology and how the water's flowing and reacting and the life that's living in it. And this is a great interdisciplinary site for studying all sorts of sciences.
There it goes.
Fantastic.
Oh,
Pulling up the
great
water.
squeeze!
1 for 7.
Oh, you got some octopuses holding on.
It's fine, take them with us.
Get off me, Michael.
They want some of our equipment.
Okay, you can zoom out there. Oh, watch out for that rock.
So we can do a second squeezer in the same spot.
All right, second squeezer in the same spot.
Copy.
So you can tell it's been squeezed because that rod in the center is
So
up.
we are going to deploy this yellow temp logger here, correct?
If we have to, yeah, we can work with that. That's not
Yeah,
a big
it's
deal.
kind of in
We
our.
have good note takers.
It's
We don't have a position for it yet, so if maybe you want to detach it, and if you could put it.
let me try without. I'll try another one. Yeah, it's.
Are you able to grab the nylon rope to pull it free?
Yeah, but then I'll be holding it with one hand, and we would have to transfer it to Mongo and let Mongo hold it, and then
You couldn't put it on the porch?
I could grab it back. I'd rather put the temp probe there.
If it provides any comfort, I've seen them handled being put down on the porch and then re-grabbed.
Oh yeah. Okay.